Hello, Honors Math 3. We continue on finding some derivatives today. I'm going to have to move a little quickly to get everything in today, so feel free to pause or go back if I go too quickly through something. We have seen that a derivative is simply a limit to find the slope of a tangent line to a function at a certain point. We can find the derivative at a single point if we have a value, or we can find the derivative, slope of a tangent line, for any value c. This will be a formula for the derivative. Alrighty, I'm going to find f prime for any value c, which is a limit, as x approaches that value c, of the slope. When I plug in x, I get f of x. When I plug in any old c, I get f of c, all over x minus c. Again, I'm finding a formula for the derivative in general, rather than just at a single value. Okay, I'm going to pause and plug in. Okay, here is f of x. Here is f of c. When I plug in c, I'm going to distribute. And please notice I cannot plug in that value of c, otherwise the denominator is going to be undefined. So after I distribute, you're going to look for a creative way to factor. I'm going to pause here. Notice my 1's cancel out after I distribute. This is the same as the limit as x approaches c. I'm going to collect my squared terms, 3x squared minus 3c squared, and then collect minus 4x plus 4c. Again, I cannot plug in x equals c, otherwise my denominator is undefined. So now I'm going to have to do some creative factoring, and I'm on my way to a formula for the derivative. I factor out a 3, factor out a negative 4. I'm getting close here to a common factor. That first thing factors is the difference of squares. I'm going to factor it and then reduce. There's my difference of squares pattern. And now notice I can remove that problem spot as x approaches c. As long as I have that common factor in all of my terms, I can reduce. And I'm left with the limit as x approaches c of 3 times x plus c, 3 times x plus c minus 4. Notice now I can plug in c, and that is defined. When I plug in c, this will be 3 times c plus c, which is 3 times 2c minus 4, which is really just 6c minus 4. So the derivative, when I plug in c, is 6c minus 4. It looks like a formula. Let me pause here for a little note. So when I plug in any c value, a formula for my derivative is 6c minus 4. We say for any x value, f prime of x, the derivative will be 6 times that x value minus 4. And we say when we can find a formula to find the derivative, we call that function differentiable. So this function is differentiable, and its derivative will always be f prime of x is equal to 6x minus 4. This is what that function looks like if I plug it in my graphing calculator. Watch this. So, what is f prime of negative 1? Well, if I go over here to negative 1, it looks like it should be a negative number. Let's try it. If I find f prime of negative 1, I plug into my function for the derivative, which is 6 times negative 1 minus 4, which is negative 10. And there you go. The slope of the tangent line at negative 1 will be negative 10. Pretty cool. Plug in x equals 3 and see what that derivative will be. I'm going to draw a function down here for another way to find the derivative of a function using a difference quotient, we call it. Sketch a function, any random function. Here's my function f of x. Alrighty, and I'm going to pick an x value. Here's my x value. And then I'm going to move to the right. I don't know, what's the difference between this x value and the next x value? In calculus, we tend to call this h, for some number h. So if I start at x and I shift to the right, h units, notice this x value is now x plus h. And I'm going to label the function values, these ordered pairs right here. And come up here and I'm going to label that ordered pair. And I'm going to find the slope of that line. Obviously it's not a tangent line, that's a secant line. But I can find the slope of that line. Okay, so again, Here's my difference of h between those x values. Here's this ordered pair. When I plug in x, what's my output when I plug in x? That's simply f of x. But when I plug in this, x plus h, what is my output? My function value will be f of x plus h. Looks messy, but it's going to lead us to what we call the difference quotient. Now watch this. Notice as that h value, which is the difference between the x values, gets smaller and smaller and smaller. If I could shrink that difference, and let's use this h value, if I could shrink that h value and find that slope again of that secant line, and if I could shrink that h value again and get even closer, notice that the slope of the secant line gets closer and closer and closer to the slope of the tangent line. And that's what we mean by finding the slope of the tangent line with the difference quotient. As that difference, that h value gets smaller and smaller and smaller, the slope of the tangent line, which is f prime of x, can also be written as the limit as that h value gets smaller and smaller and smaller as h approaches 0. Hold on. The limit as that h value approaches 0 will equal finding a slope. I'm going to do y minus y over x minus x. Y minus y over x minus x, which will be f of x plus h minus f of x all over x plus h minus x. Well, that's silly. We could clean up that denominator, so those x's are gone. And our limit, or our difference quotient, I should say, becomes the limit as h approaches 0 of f of x plus h minus f of x all over h. And this is what we call the difference quotient. Alrighty, let's see how we can find a derivative using that difference quotient. Okay, let's find the derivative of this function at 3, negative 36 using now the difference quotient from above. This means that as x values approach, x equals 3. Alrighty, so that is f prime of 3 is equal to, I'm going to pause and plug in. Plugging into the difference quotient, that's the limit as h approaches 0 of f of, now x is equal to 3 plus h minus f of 3 all over h. That looks weird. I'm going to do a little aside here. What is f of 3 plus h? That's easier for me to write as h plus 3, which is, I'm going to plug in h plus 3 into that function. Negative 4 times h plus 3 squared. Can you expand that, please? When I expand this and distribute my negative 4, I get this. So f of 3 plus h is this. That's the limit as h approaches 0 of negative 4h squared minus 24h minus 36 minus, what is f of 3? Well, when x is 3, y is negative 36, so I'm going to plug in a negative 36 all over h. Okay, simplify that, please. Those 36's are gone. I'm left with this. Notice h divides into both of those, so I can divide both terms by h. That's negative 4h minus 24. Notice, though, as h approaches 0, this whole first term, negative 4 times 0, approaches 0. And I'm really just left with negative 24. Would you look at that? That means that the derivative at x equals 3 is going to be negative 24. Ha! Don't believe me? I'm going to sketch that graph and confirm for you. An upside down parabola, pretty narrow also. When x is equal to 3, ha! The slope of the tangent line is negative, and very negative. Negative 24. That's the slope of the tangent line. Ha! Beautiful. Let's try that one more time. Okay, let's confirm that this function is differentiable by finding a function f prime of x using the difference quotient. Differentiable means that we're able to find a function for finding the derivative at any x value. So, rather than f prime of 3 specifically, I want f prime of x will equal the limit, using the difference quotient as h approaches 0, of, for any x, f of x plus h minus f of x all over h. Now, I need to find this. What is f of x plus h? That would be, plug in x plus h squared plus 3 times x plus h. We need to pause. Can you expand that, please, and combine like terms? This is what I get when I plug in x plus h into my function. There it is. Minus f of x itself, and f of x is x squared plus 3x all over h. Please distribute and combine like terms. Limit as h approaches 0, combine in the numerator. Distribute, eliminate what you can, becomes this. Divide an h out of all those terms, becomes this. Notice though, as h approaches 0, this term disappears, becomes 0, and I am left with 2x plus 3. So, a formula for my derivative, f prime of x, will equal 2x plus 3. Circle it, star it, love it. I'm going to convince you real quick that that's true. Watch this. Here's my original function graphed. If I find the slope at positive 2 using my formula, I get 7. But if I find the slope at, let's say, negative 5 down here, my slope plugging into the formula is negative 7. And it confirms using that formula for the derivative. Please read this next situation. I'm going to draw a little sketch. Okay, remember that a derivative is the slope of a tangent line. We also consider the derivative then the instantaneous rate of change. Rather than an average rate of change, an instantaneous rate of change with respect to time. Okay, let's see. So here, let's read. An object is dropped from the top of a 100-meter building. Its height above the ground after t seconds is represented by this function. So I drop something at 100 meters, and over time, the height becomes 0. It eventually hits the ground. So this is a function for height. How high above the ground is that object after 3 seconds? Please find that. This is a function for height. So how high is it? I can just plug in t equals 3, and I get 55.9 meters. What's the average speed of the object between t equals 1 and t equals 4 seconds? Pause and think about how we find an average speed. Remember, average speed is simply slope, and we use y minus y over x minus x. So in this case, I want s of 4 minus s of 1 all over 4 minus 1. You've already found your calculator, so find s of 4 and s of 1, please. Here's your outputs. Those represent meters. Over those inputs represent seconds, and I get negative 24.5 meters per second, so that the units make sense. Now let's think about how we can find the instantaneous speed, or the slope of the tangent line, which is the derivative at t equals 4. Pause for a second and think about how you would find the derivative. Ladies and gents, we now have choices. To find a derivative, we can use s prime of 4 is the limit as t approaches 4 from earlier, or we can find s prime of 4 is the limit as h approaches 0 of the difference quotient. I'm going to choose the first one, the limit as t approaches 4, and plug into that slope formula. Okay, I plug in my function and s of 4. I simplify, I factor, continue to factor, simplify, and then I can plug in t equals 4 and summarize.